Introduction to Air Conditioning Systems. Classification of air conditioning systems. There are many ways to classify air conditioners. Mainstream classifications are according to application and media. First, let's take a look at classification according to the scene used. According to the requirements of the scene, we generally differentiate comfort air conditioning from industrial air conditioning. Air conditioners used in different scenarios were designed to meet special scene requirements. For example, data center precision air conditioners need to keep the temperature and humidity constant and must ensure uninterrupted running for more than a decade. Medical air conditioners require constant temperature and humidity at all times and have special requirements for wind speed. In some commercial use scenarios, there are no restrictions on the requirements of air conditioning. Let's take a look at classifications according to media. Depending on the cooling media inside the evaporator, air conditioners can be classified into two categories: air-cooled and chilled water. This picture shows the most common type, which we call the typical structure of direct expansion air cooling. Notice that this type of air conditioner evaporator is filled with refrigerant, and the inside of the condenser is also a refrigerant. Both heat exchangers exchange heat with air mainly by convection. Next, consider the water-cooled type. Water cooling here refers to the cooling method of the refrigerant in the condenser. Water cooling is based on refrigeration, adding a water cycle to the condenser side and releasing the heat to outdoors through the cooling tower. This cooling method of the condenser has a better cooling effect, but the system is more complicated. Chilled water units are widely used in many large refrigeration applications. The heat exchange medium inside the evaporator is essentially chilled water. The evaporator here is sometimes not just one, but a group of evaporators, depending on the design. Of course, there are different structures. Many are a set of coils, which we call CW coils. This picture shows a more common type of chilled water unit. Indoor chilled water exchanges heat with the indoor environment through CW coils. In the external unit, the refrigerant dissipates heat outdoors through the condenser. From a system point of view, this kind of refrigeration system is more complicated. The primary task of the chiller is to produce a large amount of chilled water by circulating the refrigerant. The chilled water completes the indoor circulation to take heat away from the indoor environment, and the refrigerant completes the heat dissipation to the environment through the corresponding cycle. The point to emphasize is that we look at the final cooling form of the refrigerant. If the final form is air cooling, we call this system air-cooled chilled water. In this form below, the final cooling of the refrigerant is by water, so we call it water-cooled chilled water. In this form of air conditioning system, it is generally necessary to construct a cooling tower to ensure cooling. In some water-rich areas, water from rivers and lakes can be used directly to cool the refrigerant.